Hello everyone, my name is G. Shiv Prasad, rule number 21951A04J9, EC C section, and my topic name is Python for IoT, Internet of Things. Oftentimes, prototypes are real life Internet of Things. Systems need to be developed quickly and efficiently. When this happens, two tasks immediately come to life: programming the Internet of Things device and organizing a backend that interacts with these devices. In both tasks, you can use Python as the development language, or you can use a completely functional and practical version of to work and device with little computing resources and accordingly at a very low cost. Let's take a look at how you can use Python to program Internet of Things devices and create a backend for them to work. Why the Internet of Things? We can date the term of the Internet of Things to 1999, coined by Kevin Ashton. Ever since its importance and scale has exploded. In fact, one of the main indicators is its market size of $151 billion in 2018, with a steady increase year over year based on the marketers forecast for 2022. The Internet of Things market could reach the 561 billion mark. Back in the day, Internet of Things was explained with examples like this one. Internet of Things. Nowadays, hardly anyone would be surprised by a smart electricity meter that transmits readings of electricity consumption, uploads that info to the cloud, and generates monthly bills sent directly to your email. Across industries, Internet of Things is being increasingly used to streamline processes and make them more efficient. For example, manufacturing, production lines, and agriculture are great examples of different industries taking advantage of the many benefits of Internet of Things. In a specific case of agriculture, Internet of Things helps coordinate harvesters with trucks that have elevators to efficiently handle grains. Why use Python in Internet of Things? For many developers, Python is the language of choice in the market. It is easy to learn, has clean syntax, and it is supported by a large community online. In Internet of Things, Python is a great choice for the backend side of development as well as the software development of devices. In addition, Python is available to run on Linux device and you can use MicroPython for microcontrollers. In this article, it is said that using this coding language helps you reduce the volume of data that you have to deal with and that is accessible in the cloud. Regardless of whether you are creating your Internet of Things project from scratch or interacting with seniors, sensors, actuators, and accessories, Python recognizes your requirements. Some of the many advantages of working with Python for Internet of Things device are the speed at which you have can develop code and a large number of libraries for all kinds of platforms. Python is a great ally to develop advanced prototypes. Even you rewrite some of your code during production to C, C++ or Java to improve performance in general. The system will function perfectly in Python. The best solution for Internet of Things in Python on Raspberry Pi. The first thing that comes to mind about running Python on an Internet of Things device is grabbing your beloved Raspberry Pi from the table. Python is pre-installed in the operating system and the only thing left is for you to write your own script. In this case, you can control Internet of Things ports on Raspberry Pi expansion bar. Fortunately, the board supports wireless communication, Bluetooth and Wi-Fi, Ethernet, and you can also connect a monitor to the HDMI outputs, a specialized 3.2 320 into 240 TFT LCD or a low energy consumption e-ink 2.13 250 into 122 display for Raspberry Pi. The controllers available in a wide range of computing power and budgets can be choose for the Internet of Things system from the fast Raspberry Pi 4 model 8 GB to the smallest Raspberry Pi Zero, all supporting Python. If necessary, you can install the previous version of Python 2.7 for past compatibility. To control the I/O ports, you can easily write a couple for of lines in Python using the GPIO0 library. From GPIO0 import button, from time import sleep button equal to button 2 while true. If button is pressed, print button press else, print button release sleep 1. This example shows how easy it is to receive and process signals by pressing the button on the second pin at the moment of pressing and at the moment of releasing. The advantages of using this approach are the availability of a wide range of development tools, libraries, and communication for the most complex devices based on Raspberry Pi, including video processing from cameras. Python on PyBoard. The next general solution for Python in Internet of Things devices is the PyBoard with an STM4 microcontroller. The PyBoard is a compact and powerful electronics development board that runs MicroPython. It connects to your PC via USB, giving you a USB flash drive to save your Python script and a serial Python prompt, a REPL for instant programming. This works with Windows, Mac, and Linux. PyBoard runs MicroPython, a lightweight implementation of the standard CPython interpreter as written on the site. MicroPython is a lean and efficient implementation of the Python 3 programming language that includes a small subset of the Python standard library and is optimized to run on microcontrollers and its constrained environments. The MicroPython PyBoard is a compact electronic circuit board that runs MicroPython on the bare metal, giving you a low-level Python operating system that can be used to control all kinds of electronic projects. MicroPython is packed full of advanced features such as an interactive prompter, arbitrary precision integers, closures list, comprehension generators, exemption handling, and more. It is compact enough to fit and run with just 256K of code space and 16K of RAM. MicroPython is a complete rewrite of the Python version 3.4 programming language so that it fits and runs on microcontroller. It includes many optimization for efficiency and it looks very little RAM. MicroPython run bare metal on the PyBoard, essentially giving you a Python operating system. The built-in PyBoard module contains function and classes, so control operating system. The built-in the peripherals available on the board such as UART 12 SysPy, ADC, and DAC. The dimensions of the board are impressive, taking up about 2 quarters, 33 mm into 43 mm, and weighing just 6 grams. Internet of Things backend with Python. MQTT protocol with Python. The most popular connection method for Internet of Things devices is MQTT, a protocol that is effectively implemented with Python. The MQTT protocol is a machine to machine M2M Internet of Things connectivity protocol that is designed as an extremely lightweight publish subscribe messaging transport. It is useful for connection with remote location where a small code footprint is required and our network bandwidth is at premium. The Eclipse PAHO MQTT Python client library implements version 5.0, 3.1.1, and 3.1 of the MQTT protocol. The POHO library code provides a client class that enables application to connect to an MQTT broker to publish messages, subscribe to topics, and receive publish messages. It also provides some helper functions to make the publishing of one of messages to MQTT servers straightforward. Internet of Things backend on Flask in Python for a quick and hassle-free tool to write the backend for your Internet of Things systems and easily set up server-side input-output information. The Flask micro framework is here to rescue you and is packed with Internet of Things of functionalities. To get started, decide on the request you need to serve from your Internet of Things devices. Set up the Flask micro framework and write a couple of lines of code. The get method will now return information upon request from the client side. In many cases, you are best off targeting the RESTful protocol when working with your Internet of Things devices. This simplifies the exchange between the system components and allows you to expand the information exchange chain system in the future. Let's go further. Let's say the following task has arisen: display information from Internet of Things devices on a web page. The Flask micro framework will rescue you again with its built-in template mechanism where you can build the needed web page with the data display including graphics. Microsoft Azure or to internet backend with Python. Microsoft has released a new open source Internet of Things extension that extends the capabilities of Azure CLI 2.0. Azure CLI 2.0 includes commands to interact with the Azure Resources Manager and management endpoints. For example, you can use Azure Create an Azure VM or Internet of Things. The CLI extension allows an Azure services to complement Azure CLI by giving users access to additional service specific capabilities. The Internet of Things extension gives developers command lines accesses to the capabilities of the Internet of Things Hub, Internet of Things Edge, and Internet Things Hub device professional service. Azure CLI 2.0 enables immediate management of Azure Internet of Things Hub resources, device providing service instance and associated hub. The new Internet Things of extension enriches Azure CLI 2.0 with features like device management, all Internet of Things capabilities. Azure CLI 2.0 IoT capabilities, control plane, manage IoT hub instances, consumer groups and jobs, manage the device provision, service instances, access policies, linked hub and certificate, new features for extension, data plane, manage device and edge module identities as well as their respective twin definitions. Thank you.